Hello. So we are group number 34. Our group members are Ridhi Joshi, Pawan Kumar, Yogesh and myself Mehak. Our IRE project is about predicting potential buyers and their buying behavior on e-commerce sites. Our problem statement is we are given a sequence of click events performed by some user during a typical session in an e-commerce website. The goal is to predict whether the user is going to buy something or not, and if he is buying, what would be the items he is going to buy. The task could therefore be divided into two sub goals. Is the user going to buy items in this session? If yes, what are the items that he is going to buy? For classification of varied data sets into different classes using some training data and applying this on testing data to predict the class of various data sets in the testing data, there are a number of statistical methods which may be used in different combinations to obtain the required result, but it is our objective to find the correct combination which provides the optimal result. The dataset given to us has three resources, that is the clicks.dat file, bias file and the test file. The clicks and test file consist of session ID, timestamp, item ID and category. The bias file consists of session ID, timestamp, item ID, price and quantity. We faced quite a number of challenges while dealing with the dataset, such as the clicks file is very large to handle, that is 1.5 GB, and the number of items bought are very less as compared to number of clicks. And also the lack of common features in clicks and bias file, and the category variable in clicks file is too sparse and it requires to be binned. So for our feature set, the motivation was that the timestamp information given in clicks and bias datasets is not very descriptive and there aren't any common features. So the features were session clicks, which is of numeric form. It is the number of clicks in a session. Then the clicks per unique item, that is total number of clicks in a session. Then this is indicative of the importance of the item to a particular user. Then it was session span. It is the duration of the session. Buy time for an item in session. The difference between item is clicked last and the time when the item is first clicked. Then comes the time of the day, which is categorical. The time of the day when the user is browsing the session. Then category variance in a session. That is how many different categories has the user browsed in that session. Then total number of clicks for the items. This is indicative of how popular the item is. Then day of the week, which is also categorical. This tells us the day of the week. Then month, beginning or end. This is Boolean type. It tells us if the tells us about the beginning or end of the month or not. Then comes month of the year. Then median price per category, median quantity per category, median price into quantity per category. Another motivation for feature selection was that we did not have any relation between the items that are clicked and bought. So for relation between the items in a session, let I1 up to IN be n distinct items in a set. Let f be a function that represents the number of sessions where ij is bought given ik is present. Now s is the summation of all the items from I1 to ik, and then we normalize it where s denotes the session of the item. In the preliminary analysis of the problem, we made some important observations. That is, total train items were 52739 and so on. The inference that we drew from these observations is that all the purchased items will be one of the items in the buy file. For any item in a session, we will predict only from the items in the buy file whether it will be bought or not bought. We followed the approach as shown in the flow diagram. Since the number of clicks are very large, it is difficult to train the entire feature set. Also, since the number of buys are very less, training the entire feature set together may result in not buying of any item. Hence, weightage for item bought should be more. We address this problem in following ways. We are separating items that are bought from the items which are not bought from the final click file. We are randomly picking items from not bought file with the total instances rows equal to number of rows in bought file and concatenating them in a new file. This process is repeated 11 times. In short, we have 11 different train files. Each of the train file will be trained separately. Hence, during testing, we have 11 different outcomes for each test row, which could be bought or not bought. If the number of bought is greater than the threshold, in our case it is greater than or equal to 3, then we consider the particular items in the session as bought, otherwise not bought. The value for this threshold was obtained by k-fold cross validation with k equal to 10 and score equal to 89%. For the analysis part, we plotted the graph between the specificity and class weight, then bias versus time, which is a normalized graph, and so on. The ablation experiment. In this, the motivation was that the category is a sparse feature and it has too many missing values, hence dependent features are affected. Item relation is dependent on buy file, hence has to be extrapolated for test dataset. We aimed at three main things. We should know the effect of item relation on model accuracy, determine how good are median price quantity per category features, is category variation a positive feature, this is the evaluation method that we followed, where SI is the sessions in submitted solution file, S is all sessions in the test file, small s is sessions in the test set, SB sessions in test set which end with buy, AS is predicted bought items in session S, BS is actual bought items in session S. And we obtained a score of 33,179. Thank you.